Lesson 2.1 is dealing with graphing and writing inequalities. So we've talked about inequalities before, but in case you remember, in case you don't remember, there's a couple different symbols involved with inequalities. We have less than, greater than, less than or equal to, greater than or equal to, and then we also has is not equal to. When we have the equal to, that means the solution or the number that we're comparing, our variable 2 is included in the solution set. So a solution of an inequality is any value of the variable that makes the inequality true. Okay? And an inequality is a statement that two quantities are not equal. The quantities are compared by using these symbols. Okay? So they're not equal, but one might be bigger or smaller, or they could possibly be equal to because we do have less than or equal to and greater than or equal to. So, first, example 1 says describe the solutions of 3 plus 1x is less than 9 in words. Okay, so here we have the inequality, 3 plus x is less than 9. So that means any value for x plus 3 is less than 9. So we have to find what values for x work. So here you can test out some different numbers and see what works. Okay, they tried a negative number, 0, positive number, and some other positive numbers as well to see what actually satisfies this inequality, makes it true. So here you could actually subtract 3 from both sides, just like an equation. Okay, and then we're left with x less than 9 minus 3 gives me 6. So any value that is less than 6 is going to work for this inequality. So the solutions of 3 plus x is less than 9 are numbers less than 6. So there's a check it out problem. Number 1, it says describe the solutions of 2p greater than 8 in words, or 2 times p is greater than 8 in words. So go ahead, take a moment, pause the video, and answer this question. So for this case, all real numbers greater than 4 would work. Because 2 times 4 would give me 8, okay, and I can't be equal to 8 because it's strictly greater than. But anything above 4 would work. So like 4.1, 4.2, 4.00001 would also work. So anything greater than 4. So now we're going to get into graphing inequalities. So an inequality like 3 plus x is less than 9 has way too many solutions to just list out. So we can visually represent the solution set by graphing it. So you can graph on a number line to show all the solutions. The solutions are shaded and an arrow shows the solutions continue past those shown on the graph. So to show an endpoint is a solution, you're going to draw a solid circle at the number. To show that an endpoint is not a solution, you draw an empty circle. So when I have greater than and less than, you're going to have an open dot, open dot. So on your graph, it's going to look like this. If I have greater than or equal to, less than or equal to, those guys are going to have closed dots. This means the solution or that number that the dot is on is included in the solution set and makes the inequality true. So you would fill in your dot. Okay. So some examples here, all real numbers less than 5. So x is less than 5. So 5 is my important number, so that's where my dot's going to go. It's less than is an open dot, so it's kind of hard to see, but it's open. It's not filled in there. There's some space, okay? And then you shade to the left, okay? Because all numbers less than 5 are to the left here, and then you draw an arrow to show that the solutions are going to continue to the left forever and ever, okay? All numbers greater than negative 1. X is greater than negative 1, so my important number is negative 1. So there's going to be an open dot at negative 1. because it's just greater than, and numbers bigger than -1 will be shaded in. So I'm shading to the right, and then my arrow goes to the right. The third one, all real numbers less than or equal to 1/2. X is less than or equal to 1/2. 1/2 is my important number. I have an equal to closed dot. So dot's filled in, you can't see in it, and then we're shading to the left, arrow goes to the left. All real numbers greater than or equal to 0. X is greater than or equal to 0, so my important number is at 0. Dot's filled in because I have equal to, shading to the right. Okay? So now we're going to try some together. So we have B is less than -1.5. So I'm going to draw my number line. When you draw your own number lines, you can use scaling what you want to be, as long as it makes sense for the problem, and your important numbers on the number line. So I'm going to put -1.5 right in the middle, and then go -1, -0.5, so I'm counting by 0.5, and then -2, -2.5. All right, so now I'm going to go ahead and graph. So here I'm at -0.5, so I'm going to have an open dot at -0.5. B is less than, so since B is less than, I shade to the left. So any number smaller than. So I shade to the left, and then I draw my arrow to show that it keeps on going to the left. So that is what your graph would look like. Second one, R is greater than or equal to 2. So I'm going to set up my number line. So I'm going to put 2 in the middle. I'm going to count by 2s this time. So 2, 4, 6, and then 0, -2. Again, choice is up to you what kind of scaling you want to do. Now I have the equal to, important number is 2, so I'm going to put a closed dot on 2. And this time I'm going to shade to the right. If you're not sure which way to shade, it's helpful to pick a test point to the left and right. So if you pick -2, is -2 greater than or equal to 2? No, it's not. That doesn't make sense. You wouldn't shade to the left. You could try 6 on the right side. So is 6 greater than or equal to 2? Yes, it is. So you're shading to the right. Okay, so if you need to do that quick little check to figure out which way you're shading, you're more than welcome to, and that should help you out. There are 3 check it out problems for you to try. So go ahead, pause the video, try these 3 on your own, and then resume the video when you're ready to check your answer. So starting with A, we have C is greater than 2.5. So I'm going to put 2.5 in the middle, and then I'll have 3 over here, and 2. So I'm increasing by 0.5, scaling by 0.5. I'm just strictly greater than, so I'm going to have an open dot at 2.5. 2 is not greater than 2.5. 3 is greater than 2.5, so I shade to the right here. So I'm shading to the right and drawing my arrow to show that it's going to continue to the right. B, we have 2 squared minus 4 is greater than or equal to W. So we have to simplify a little bit first for this one, because we don't have just a number over here. We have an expression that needs to be simplified. So by order of operations, you do the exponent first. 2 to the second is 4. So I have 4 minus 4 is greater than or equal to W. 4 minus 4 is 0. So I have 0 is greater than or equal to W. And if you want, you can rewrite this to have the W come first. So W, okay, now my sign's going to flip, so it's going to be the other way. W is less than or equal to 0. Okay, so I'm just flipping the W and the 0, and then the sign also flips. So it's still, the mouth is still opening up towards that 0. If you want to think about it as the alligator eats what's bigger. So 0 is bigger, 0 is bigger. Okay? And now I'm going to draw my number line. So we have 0, say 2, 4, and then over here, -2, -4. Now I have the equal to. 0 is my important number, so I'm going to draw a dot filled in, a closed dot at 0. 0 is greater than, so W is less than. So is -4 less than 0? Yes. Is 4 less than 0? No. So I'm shading to the left here. So shading to the left, drawing my arrow to show that my solutions continue to the left. And then C, we have M is less than or equal to -3. So I'm going to draw my number line. I'm going to put -3 in the middle. And then we have -2. And then -4. Less than or equal to, -3 is my important number. It has the equal to, so dot's going to be filled in. And then M is less than or equal to -3. Okay. Is -4 less than or equal to -3? Yes. Is -2? No. So I'm shading to the left here. And then I'm drawing my arrow. So those are the answers for those 3 problems. Now we're going to go ahead and look at example 3. So for example 3, we are going to write the inequality shown by each graph. Okay, so instead of drawing the graph, this time you're looking at the graph, writing the inequality. So the first thing you always want to do is you want to pick a variable. Okay, it doesn't matter what variable you pick. I always default to X because X is used most often. If you have a favorite letter that you want to use, you're more than welcome to. Or if the problem says let your variable be M, then use M. Okay, but if not, your choice. Okay, so I'm going to use X. Then I leave some space here. Then I look for my important number. Your important number is where your dot is. So my dot is at 4.5 here. So I'm going to leave some space, write my important number, 4.5. Now X is the spot that's shaded over here. So X is over here. Okay, so now I need to figure out what's bigger. Is X, the shaded area, bigger, or is 4.5? If you're not sure, pick some numbers in this shaded area. So 5's in that shaded area. Okay, is 5 bigger or is 4.5 bigger? Well, 5's going to be bigger, so that means X has to be bigger. Okay, and then I have an open dot, so I don't have an equal to. So my inequality is X is greater than 4.5. I'm going to follow the same process with B. So I'm going to write my variable, X, leave some space. My dot is at -3, so I'm going to write -3. Now I'm going to pick some test numbers. Okay, so over here I have -5, -4, and then I also have a closed dot, so -3. So what's bigger? Is -5 bigger or is -3? Well, -3 is bigger. Is -4 bigger? Or is -3? -3. Is -3 bigger or -3? Well, those are going to be equal. So we're going to have 2 parts to our inequality. We're going to have that X is less than -3 because -5 and -4 are smaller. But then we're also going to have the equal to because -3 could be a solution. So X is less than or equal to -3. And that would be the answer to this inequality. All right. There is a check it out problem for you to try. So go ahead, pause the video, write the inequality shown by the graph, and then resume when you're ready to check your answer. So here, I'm going to write my variable X. My important number is 2.5, so I'm going to leave some space and write 2.5. My shaded area is to the left over here, so I have numbers like -5, -2, 0. Okay, there's many options over there. So now I need to see, is -5 or 2.5 bigger? Well, 2.5. -2 or 2.5? 2.5 is bigger. Is 0 or is 2.5 bigger? Well, 2.5 is bigger. So the inequality opens to 2.5. So X is less than 2.5. Open dot, Open dot means there's no equal to, so 2.5 isn't a solution. So my answer here is x is less than 2.5, and that would be your final answer. And if you picked a different variable, you're just going to have a different letter besides x, but your answer would still be correct. Example 4. So it says the members of a lightweight crew team can weigh no more than 165 pounds each. Define a variable and write an inequality for the acceptable weights of the team members. Graph the solutions. So no more than 165 pounds each. So each athlete can only weigh 165 pounds, no more than that. So W is going to represent the weights that are allowed, how much the athlete can weigh. No more than means it has to be less than or equal to. The biggest that it can be is 165 pounds. So our inequality is going to be W is less than or equal to 165. And then we're going to graph it. Okay, so 165 is our important number, so we would plot that. Equal to, so close dot. And then we shade to the left. Now here the graph stops at 0 because no one can weigh less than 0 pounds. So some real world examples you're going to have a limit on both ends. So the athlete has to be between 0 and 165 pounds. Can't equal 0 because that means that person doesn't exist. They don't weigh anything. So we have an open dot at 0. So it goes from open dot at 0 to close dot at 165. There is a check it out problem for you to try. So go ahead, pause the video, try this one on your own, and then resume when you're ready to check your answer. So 4 says a store's employees earn at least $8.25 per hour. So at least $8.25 per hour. Define a variable and write an inequality for the amount that the employees may earn per hour. Graph the solutions. So we're going to define our variable. Okay, your choice what you want to use. I'm going to use x. So x equals amount employee earns per hour. So I have x. I'm going to leave a space. My important number is $8.25 or 8.25. At least $8.25. So at least means it can be equal to $8.25 or it has to be bigger. The smallest it can be is $8.25. So x is going to be greater than or equal to $8.25. Okay, so at least $8.25. And now I just have to graph it. So I defined my variable, I wrote the inequality, and now I need a graph. So I'm going to draw a number line. I'm going to put $8.25 in the middle. And then I'll have $8.50, $8.75, and over here $8, and $7.75. All right, so I'm going to have a closed dot because it's equal to at $8.25. So closed dot at $8.25. And then I'm going to shade to the right because x is greater than. We want a number bigger than $8.25. Or it can be equal to because we have the closed dot. So shading to the right, and then I draw my arrow. So your graph would look like this.